Hi everyone, welcome back. Today we're talking about 7.5, which is solving rational equations. The logical progression of this chapter, it goes from simplifying rational expressions to adding, subtracting, multiplying, and dividing rational expressions, all to prepare for solving rational equations. So today's the day where we get to solve some equations, not just simplify everything. So we're looking at fractions, right? So whenever you're solving an equation with fractions, there's a few techniques that you use, and one is solved by cross multiplying. Another is just multiplying the entire equation by the least common denominator. And you can also solve these by just combining one side and then cross multiplying. So we'll talk about all these techniques kind of as we go through the lesson. So the first one we're going to talk about is cross multiplying. So in example 1, when you have one fraction equal to another fraction and there's no addition or subtraction, this is a situation where I would just straight cross multiply. So remember back in the day where you have like a over b equals c over d, and you cross multiply. So it would be a times d is equal to b times c, and then you can solve from there. And that's of course as long as b and d don't equal 0. So cross multiply. You got 3 times 4x plus 5 equal to 9 times x plus 1. Now, we do have a domain restriction on this. We know that in the first fraction from the very beginning, when x plus 1 is equal to 0, your fraction's undefined. So we know that x can't equal -1. And also in the second fraction right there, set 4x plus 5 equal to 0 and solve, and you'll also have x can't equal -5 over 4. So if you get answers of -1 or -5 over 4, you know you have a problem and you have what we call an extraneous solution. And so you would throw that answer out. All right, so getting back to the problem, we have our cross multiplying all set up. So now we distribute. We've got 12x plus 15 is equal to 9x plus 9. And we have x's on both sides of your equation, so we'll subtract 9x, subtract 15, and you have yourself 3x is equal to, those drop out, your 9x's drop out also, and you're left with -6. And divide both sides by 3, and you get x is equal to -2. So, especially in this section, you should always check your answer. So check answer and make sure that you got it 100% correct, because if you hypothetically got a -1 or a -5 over 4, that would not work. That would not satisfy the equation. So do a double check. 3 divided by -2 plus 1, does that equal 9 divided by 4 times -2 plus 5? And you say, well, 3 over -1, that's the same as, 9 over, that's -8 plus 5, which is -3, and that definitely checks out. Okay, so we box our answer. Move on. Extra example 1 is another situation where I would cross multiply because I have two fractions just set equal to each other. There's no addition or subtraction happening. So cross multiply, you get 2 times 3x plus 2. That's equal to 10 times x plus 2. Distribute. You get 6x plus 4 is equal to 10x plus 20. Subtract your 6x to get them both on the same side, or both x's on the same side. Subtract your 20, kick them out. You're left with -16 is equal to 4x, and divide both sides by 4. And you got x is equal to -4. And do a double check. 2 divided by -4 plus 2, does that equal 10 divided by 3 times -4 plus 2? So 2 over -2, is that equal to 10 divided by -12 plus 2? So 2, that's a -1 equal to -12 plus 2 is -10, so a -1. So those are equal. We'll box our answer of -4 and proceed on. So cross multiplying, I think you're probably all great at. Just make sure you don't end up with an answer that is part of your domain restriction. So check your answers. So another technique that we use is just multiplying through the entire equation by a least common denominator. If you take a look over here, this is a problem that you can solve right now that you've done before. So the technique that I'm going to show you is take a look at all your denominators, all of them across the entire equation. And what's common? What's a least common multiple of 2 and 5 and 1? And you would say 10. So really, technically, what you're going to do is you're going to multiply every single fraction on the left and on the right by that 10. So you're going to go 10 times 10, I'll add parentheses, I guess, times another 10, and that will actually cancel out all your fractions. So 10 over 1, see the 5 and the 10 will simplify to be 2 over 1. So 2 times 2x gives you 4x. 10 divided by 2 is just 5. And you have 7 times 10, 70. So we're allowed to do this because we didn't actually, what we did to one side is exactly what we did to the other side of the equation. And you could proceed on and solve, right? So now we're just going to do the same idea, but with usually variables in the denominators, like in example 3, a. So you take a look at 3 over x plus 5 halves is equal to -12 over x. And you take a look at all your denominators and you think, what's a common multiple of 2 and x? And you would say 2x. So we're going to multiply every single fraction by 2x. So 2x, I'll go over 1 times 2x. Actually, that's going to get messy, so I'm going to drop down here. So 2x times 3 over x plus 5 halves times 2x is equal to, I'll give the negative up to the -12 to the 12 to write it as -12 over x multiplied by 2x. So I really just multiplied through that common multiple of 2x. And now I simplify. So put it over 1, over 1, over 1, keep your fractions lined up, and you'll see the x cancels with this x, and you're left with just 2 times 3, which is 6. The 2's cancel out here, and you have plus 5 times x is equal to the x and the x here cancel, and you're left with -24. And that's a whole lot easier than trying to add the left side, making common denominators, and then cross multiplying. This is a nice little technique that you can use to make these problems a little bit simpler. So you got 5x is equal to -30, divide by 5, and you have x is equal to -6. So do a double check for yourself. Make sure that 3 over -6 plus 5 over 2 is in fact -12 over x, or -6. Simplify it down. This gives you -1/2 plus 5 over 2. And does that equal -12 divided by -6 is +2. So 5 over 2 is 2.5, and you're subtracting a half, so you've got 2 is equal to 2. So here's your answer. For our next example, like 1 minus 2 over x minus 4 equals 4 over x. We're going to take a look. What's our denominators? X minus 4 and x, so we need a common multiple between those. So we're going to take both of them, multiply them, and we're going to multiply every single term by that x times x minus 4, and your fractions will drop out. So first off, we're going to take 1 multiplied by x. Let's write it as 1 times x minus 4 minus 2 over x minus 4, and we're going to multiply that by x times x minus 4. I'm going to put over 1 just so we can cancel out a little bit, and equal to the 4 over x times x minus 4. Same story, put it over 1 so we'll cancel things out. I guess we don't need parentheses. I can change those if it makes it easier on your eyes. So multiply, multiply. Alright, so our term here, we're just going to leave for now. And you have x times x minus 4. And what you can do is simplify a little bit. You have a common factor in the numerator and denominator there as you multiply across. So that term would just be a negative 2x. And across your equal sign, you'll have a cancel out of the x terms, and you're left with just 4 times x minus 4. Now, if your all your fractions don't disappear, then maybe you didn't multiply by a least common multiple of them. So your fractions should all drop out at this point. And all we have to do is give it a little distribute on both sides of your equation, combine our like terms, and solve. So we've got x squared minus 4x minus 2x is equal to 4x minus 16. Keep going. We've got x squared minus 6x is equal to 4x minus 16. Combine your like terms. So we'll subtract 4x from both sides. That'll give you a negative 10x. And looks like we're going to have to solve by factoring, so I'm going to bring over the 16, make it positive, and factor. So what are the factors of 16 that add up to be negative 10? And you say 8 and a 2. So they would both have to be negative for that to work. So we have to solve, split and solve. So we're going to take this, set it equal to 0, and x minus 2, set it equal to 0, and solve each one. So x minus 8 over here is equal to 0, and x minus 2 is equal to 0. Add 8 to both sides, you get 8 and 2. So those are our options. We just have to make sure they both work. So you can check those in your calculator, and they should both work out. Okay? Moving on, here's another example, just a little extra layer that you have to factor. In this denominator, that's a difference of 2 squares, so it'll factor into x plus 1 times x minus 1. And so your least common multiple would be the x plus 1 times x minus 1 that you multiply every term by. So multiply through x plus 1 times x minus 1. So let's do it. We've got 4x plus 1 divided by x plus 1 multiplied by x plus 1 times x minus 1. I'm trying to show you every step here. You don't necessarily have to show all of this, but just comes across better, I guess, in the video. So here's the term. We're going to multiply by that denominator over 1 plus 3 times x plus 1 times x minus 1. All right, so now at this point we can cancel and our fraction should disappear. So x plus 1, that gives you 4x plus 1 multiplied by x minus 1 equal to, see, these are nice because they just fully drop out and you're left with 12 plus 3 times x plus 1 times x minus 1. And we're going to distribute a little bit, combine our like terms, and finish solving. So this will give you 4x squared minus 3x and a minus 1. I did some of that in my head just so you know. 12 plus, we'll distribute in here, 3x plus 3 times x minus 1. Getting closer. 4x squared minus 3x minus 1 is equal to 12 plus 3x squared minus 3x plus 3x, that's kind of nice, that dropped out, minus 3 minus 3, and keep going. My minus 3 will combine here, and I'm running out of room. So we have 4x squared minus 3x minus 1 is equal to 9 plus 3x squared. Keep solving, so subtract 3x squared and you get x squared minus 3x minus 1 is equal to 9, and keep going. We're going to have to solve by factoring. So x squared minus 3x minus 10 is equal to 0. Factored, you get x minus 5 and x plus 2. And so your solutions here are 5 and negative 2. And do a double check. Plop them into your calculator. Make sure that it works out in the beginning of the equation in both of them. All right. Here is where we're going to get into some extraneous solutions. So some of these get complicated. You'll take care of everything if you're just checking your answers. All right. So 4 is as ugly as it can possibly get for you. All right. So take a look. You've got 6 over x minus 3. You've got a perfect square right here of x minus 3 times x plus 3. And you have another denominator of that factor of x plus 3. So we're going to multiply every single fraction by that actually difference of two squares of x minus 3 times x plus 3. So let's do it. 6 over x minus 3 times x minus 3 times x plus 3 over 1 is equal to 8x squared over that. I'll leave it in factored form, times x minus 3 times x plus 3 over 1 minus 4x divided by x minus x plus 3 multiplied by x minus 3 times x plus 3. All right, once we do all that, now we get to cancel a bunch, and our fractions will drop out. So you're left with 6 times x plus 3. Over here, both of these factors drop out, and you're left with 8x squared. And x plus 3's drop out. You're left with negative 4x times x minus 3. And a little distribute and combine. You get 6x plus 18 is equal to 8x squared minus 4x squared plus 12x. Combine all your like terms. This gives you 4x squared plus 12x. Okay, kick everything over to one side. You have 4x squared plus 6x minus 18 You can factor that. Take out a GCF of 2. You're left with 2x squared plus 3x minus 9. And we can drop it into our tic-tac-toe grid to factor. So 2 and a negative 9 is negative 18. Positive 3 goes in the box. Now you think, what are the factors of negative 18 that add up to be 3? And you can do 6 and 3. We'll make a 3. So we would have to have a positive 6 and a negative 3. And complete your box. So 1, a 2. 2 times 3 will give you 6. And 1 times negative 3 will give you negative 3. And it works vertically. 3 times negative 3 equals negative 9. So your factors lie diagonal. Whew. And here we go. We've got 2 times 2x minus 3 times x plus 3. So right here, we've got a solution of x is equal to 3 over 2 when you set it equal to 0, and x is equal to negative 3. Now you have to plug them all back in, and you'll notice that the answer of x is equal to 3/2 works. And then let's take a look. I'll show you what happens. You got 6 divided by, plug in negative 3, where x is. You got negative 3 minus 3. That fraction's okay. Plug it into x times negative 3 squared. And in the factored form, you would drop in negative 3 minus 3, which that factor is okay. But when you have this right here, negative 3 plus 3, that created a 0. And you also see it over in your second fraction on the right-hand side, because you have negative 3 plus 3. So right here, these two fractions, this guy is a 0 and this one is a 0, so you have the division of 0 of your fractions, so those fractions are actually undefined. So that's called an extraneous solution. Whoa, that's weird. Try that. Solution to your problem. And so he is not a part of your solution set. Make sure you delete him. All right, and that's a wrap.